Hey guys, so I feel horrible that I confused you, so I want to make sure that I am 100% clear on this problem. So let's go ahead and take a look at this basketball player. He is jumping vertically, so we have a parabola. Or if you guys want, you could just say like up and down, that would also be okay. Like he goes up and then he comes back down. There would be nothing wrong with that. That is okay. I'm going to go ahead and draw the parabola. All right, trying to make it semi-even here. Okay, I think that looks pretty good. This is the start of his jump. This is the top of his jump. This is the bottom of his jump. I know here that y, I want to change the size of my pen. Oh, let's see. I know here that y is 0. I know that t is 0. I have no idea what his initial velocity is. I know way up here that v is 0 because it's like, he was positive going negative. You had to hit 0. I do not know the time. We did discuss in class that this y value is 76 centimeters, so 0.76. In addition, I know down here, I know I have y being 0. I do not know the time. I do not know the velocity. They had a couple of questions about the 15 centimeter mark. So we're going to go ahead and focus in on that 15 centimeter mark. Part A is about the top 15 centimeters. So I'm just going to draw a pink line, like the top 15 centimeters being from here to here. So all that I know about this pink area is that y is 61 or 0.61 meters. Let's clean that up. I do not know my time. I do not know my velocity. And over here, I know that my y is 0.61 centimeter or meters, excuse me. I do not know my time. I do not know my velocity. So it's kind of like the main idea so far. All right, and this one, just part A, is in the top 15 centimeters. So how long is this time to this time? So what is the overarching time? There's a couple things to do, but I do know that something that I can find, or I know the most about, is this middle area. I know I don't know the time. I could get it if I wanted to, but I do at least know the velocity up there, which, thinking back to some of my equations, does tell me that I could probably find the initial velocity here. So sometimes what we do as students or as learners, myself included in that, we just really want to jump in and try to find the ones that it's asking about. But really, I know very little about those items. And I do know that one of my formulas has VO in it, and VO is a semi-important thing to be looking for. So here's what I'm going to do, okay? I have my formula that it's my velocity at where I'm looking at is equal to my original velocity of where I'm looking at plus my acceleration times my time. Now let's make sure you understand that this time is from this velocity to this velocity. So I'm going to be extremely, extremely, extremely particular because I know the most about those blue areas. This velocity is going to represent the velocity at the top. This velocity I'm going to represent as the velocity at the beginning. This time is from the beginning to the top. I feel like I'm spelling beginning right, or wrong. Oh my gosh, I just have to do this. I'm just going to roll with it. All right, so my velocity, oh, and I know my acceleration. And does it say anything about the time for him to get to the time? It does not. Okay. So I wonder if I could find that time. A couple things that we can do, a couple things we could do. Just thinking it through, thinking it through. Okay. I have too many unknowns for this. So I'm just going to hold off on this. Let's see what else I can do. Because I don't have the time, so that's actually not as hopeful as I was hoping for. Oh, let's see. What about this formula? Let's see, I'm looking, what about y equals yo, or actually, I think there's a different one. Let me see if, can I pull it up? Do I have this in my pictures? There it is. Let's look at these, shall we? Ooh, did I put it in? I'm sorry, I feel like, whoa. Okay. I get you. Okay. All right, guys, just, oop, don't want this one. Sorry. Let's see. What about this one? This y, aha, look at the bottom one maybe? Let's look at this one. Y minus, da, 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 da. Oh, dear heavens. Sorry. I'm going to look at this bottom one because I think this one might be the ticket. Y minus YO equals V times T minus 1/2 AT squared. Now, what in the world is that going to help me solve for? Let's see, let's see, let's see. I wonder if I compare, oh, maybe I could compare that. What if I make this the Y, I make this the 61, and I make this the, no, sorry. What if I make this the 76? So this is at the top, minus the 61. This is like when it enters that 15. Okay, this velocity is the velocity. See how it doesn't have an O? That velocity is the velocity at the top. There, that one will be really nice because that's 0. So that's just going to go away. I know my acceleration. Ooh, t squared. Oh, okay, okay, okay. So what this t is going to tell me, this t is how long it spends from 61 centimeters to 76 centimeters. I'm going to say that again. Okay, this t, I had to take a moment and just gather my thoughts. This t right here that we're solving for, well, first of all, this is 0, right? This t is the time, labels are so important, at least for me, 61 centimeters to 76 centimeters. That will solve for that time because those are the distances that I'm using and it's the velocity that corresponds. This one corresponds to that one. Okay, so that's going to be 0.15 at delta 15. That's going to be a positive 4.9 when you multiply these items together right here, t squared. When you divide, I can grab this calculator right here. When I do 0.15 divided by 4.9, that's the time I get. So I'm just going to write out a whole bunch of digits here. 0.03061224449. That equals t squared. So what I'm going to do now is I'm going to grab my calculator, and I know I have a square root button here. Then I can just click on that. And I get a time of 0.17496. So if I'm looking for two significance, I guess, or three significance even, because I think this problem talked about three significance, three significance, I'll go ahead and do 175 seconds. So what is 175 seconds? That is from 0.61 to 0.76 meters. So since it has to go back down, I need to double that. So 0.17, I'm actually going to do 496 times 2. So I'm just going to hit times 2 on my calculator. And now I can see with three significance, that's 3499. Three significance is actually going to be 0.350 seconds. So that's going to be to go from here to here is from here to here is the 0.1750, and then this is another 1750. So you double that, and that's how you get that particular answer. That's how I did it. That is not necessarily the way you have to do it. Okay. Now, here's our jump again. So let me just copy my picture if I can. I think that's going to help me here. Copy and paste. Okay. All right. Now, I think it asked part B, asked about the bottom 15. Okay. So that's going to be, let me change back to my pink. That's going to be like right here. And if I make a straight line-ish to like right here. So how much time here plus how much time here? All right, so I know y is 0.15. I do not know v. I do not know t. So I'm going to do the same thing over here. I know y is 0.15. I do not know t. I do not know v. All right, now I can just like say what equations I was using, but I think it'd be good if you, let's see, let's go pick one and say why. I would love to know the time here. I mean, that would be phenomenal. So let's grab some equations. I know I have them. Get rid of our calculator here. I'm going to go grab my equations, okay? Bring them down here. And I can try the first one. I might actually just make my way through my equation and talk about, because that's a skill that a lot of kids are missing. They just don't know what ones to use. So how about this? Well, I don't know my velocity. That would be this velocity. I don't know it. I don't know this velocity, so automatically I'm not picking that equation. Let's try another one. Um, let's see here. What if I do y equals yo plus vot? No, I don't. I already see I'm not going to use this one because I don't know. Whoa, wait a second. I do know y. That would be 0.15. I do know yo. I don't know v. I don't know t. Okay, let me get rid of that one. I'm not using that one. All right, now, what about v squared equals vo squared plus 2a x, or y, because y minus yo. Let's see, whoops, let's go through and see what I don't know. I don't know v squared. I don't know vo squared. Ugh, bummer sauce. And then I do know those other two. Okay, that's fine. And I'm not doing a substitution if I don't need to. That's all right, guys. Let's just make our way through. How about y minus yo equals 1/2 times vo plus vt? Okay, let's go see if we know any of this. We know y, we know yo, we don't know those v's, and we don't know those t's. Okay, last one. Now, if that last one doesn't work, I've got to think outside the box. So that last one is y minus yo equals vt. I don't have enough here. Minus 1/2 at squared. All right. So just kind of thinking that through, I have no idea what, I know those two. I don't know the velocity or the time there. So that one's out as well. All right, so that means that we're just going to have to but something I noticed I didn't have, like in all of these, was VO. It would be so nice if I could figure out what VO was, because that's like such a commonality between all of these equations. So what if I use my knowledge base? What if somehow I can find VO using my max height? I bet you I could. In fact, I'm sure I can. So let's talk about the position of yo being 0, like way at the beginning, and then let's look at that at being 0.76. So let's look at the beginning to the end, or to the max, silly me. All right, so in other words, I'd love to find VO. All right, let me see. What about, no, just going through them. The second one, yes, yes, no, no. The third one, yes. The third one's our ticket. The one that I'm putting a star by. That's the one we're using. So v squared at the top, vo at the beginning, 2 acceleration, y minus yo. We totally have this. Okay. So just so you are aware, big, big, big ticket here. This y corresponds to that velocity. This yo corresponds to that velocity. Okay, so the velocity at the tippy, tippy, tippy top. So this is the top. This is the beginning. I love labels. The more labels you have, the better. Okay, wrong. Oh, okay. I found it. That was so dumb of me. Okay. I had to rewind my video because I did top minus beginning wrong. Okay, so it's v squared equals, wait. Okay, rewind, Amy. Sorry, my kids are coming. I'm getting all anxious. Okay, so this v squared is the velocity at the top, so 0 squared. This velocity squared is unknown because it's at the beginning. 2 times negative 9.8 for my acceleration. My top is 0.76. My beginning is 0. I had to redo my video because I made the beginning 0.61 like a dodo brain. All right, so it's 0 squared, original velocity squared. Let's do 2 times, oopsie, 2 times negative 9.8 times quantity of 0.76. I can't believe I'm doing minus 0. I'm sorry. All right, so negative 14.896. I'm keeping all my decimals until I solve. So I just essentially need to take the square root of that 14.896 when I move it over. Okay, so 14,896. I just like to keep. All right, there we go. So my original velocity at the beginning of the problem, if we're doing three significance, there we go. So it's 386. All right. Now remember, I was like, hey, I'm just gonna take a pause because I wasn't able to find what like I really needed. So this was almost like a pause, and it was like my help me, help me identify something that I can use. And now I have everything I can use. All right, remember our ultimate goal right now is to find, my goal is to find this t value right here with a star. But because we just worked so hard, is that supposed to be an equal sign that I lost in my formula there? Yeah. Because we worked so hard getting VO, we really could probably find a lot of stuff here. So let's see here. I do not know my velocity. I do not know my velocity at that spot with the star, and I don't know my time. That's okay. So I won't use those, right? Let's keep going. I know my position. I know my original position. I know my original velocity. I don't know my time. That's okay. That's what I wanted to solve for, right? I just want to see if there's an easier equation without squares. Because if I can avoid squares, I'm going to avoid the squares. Okay. So I just erased something. Oh my dear heavens. Hopefully that's right. That was a Y. Got excited with my eraser. All right, what about this one? What about, oh, come on. Do we know it? Do we know it? Do we know V? No, poopy. Okay, let's do this one. Do we know yes, 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 no, no? Oh, I was hoping to avoid a square. That's okay. Yes, yes, no. Okay, I have to use this one. I have to use that one. It's the only one that has one unknown. All right. So in this little area, when I say this area, I mean this area right here, folks. I'm sorry. My ending y is 0.15 equals. My beginning y was 0. My original velocity was 386. My time is unknown. Plus 1 half negative 9.8 t squared. Okay. 0.15. I'm going to set it equal to 0. This is quadratic. You'll have to use your quadratic formula. So that would be 0 equals negative 4.9 t squared plus 3.86 t minus 0.15. If you do your quadratic formula, I'm so sorry I'm not doing it for you because I don't have time. If you do your quadratic formula on that, I'm double checking. Ah! You will get 2 times. You'll get 0.04101 and point oh, wait, no, not oh, 0.7465. Which one of those makes sense for this particular jaunt? It's not the second one because that would be way over here, right? I don't know where my undo button is. Oh my gosh, all the kids are coming in. It's totally fine. I'm going to pick the first one because it's from this the first time that it went from 0 to 15, not the second time it went from 0 to 15. And then because it's a perfect parabola, you can double this. And when you double it, that's where you get your 0.082 seconds. Done.